Hello and welcome to Concept 3 notes in our Intro to Chemistry unit. We are now going to talk about matter. So this is now our first chemistry specific content of the unit. But remember, everything we've talked about so far is still very critical and relevant because chemistry is a quantitative science. So we need to be comfortable using measurements and problem solving with numbers like we did in Concept 1. And we need to be comfortable using really large and really small numbers, which is what we needed practice with in Concept 2 with learning dimensional analysis and scientific notation. So all of this is important in our foundational Introduction to Chemistry unit, but now we're really going to get into what matters with matter. That's my cheesy intro for you. Okay, so let's do a little overview here. Chemistry is the study of matter. And you've probably taken, a biology class before. Biological sciences, we're studying living things. Physical science, we're studying non-living things. And chemistry, because it's a study of matter, it's really essential to biological and physical sciences because everything has matter. And in chemistry, we're going to look at the composition of matter, the structure, and we're going to look at the properties because something we're going to see is the structure or the composition of something, what makes it up and how it's made is going to determine how it behaves, its properties, how it acts. Chemistry also looks at the processes of matter, what the matter goes through, and how energy changes during those process changes. So we need to know what matter is. Since chemistry is a study of matter, we got to know what it is. It is anything that has mass and volume. So mass is a measure of the amount of matter. And then volume is just a measure of how much space something takes up. And everything is made of matter. Okay, so we're going to be looking at so many different things of this. And there's so many different subcategories of chemistry too. But this is really what we're looking at this year is the composition, what makes matter up, and then how that determines how that matter will then behave. Because what is going on a microscopic level in matter is determining what we see on a macroscopic level with our eyeballs on a day-to-day basis. And so that's where chemistry really matters and is important. And it's really interesting stuff. So we can't talk about matter without talking about atoms. Atoms are the building blocks of matter. An atom is the smallest unit of an element that maintains the identity of the element. Okay, so for example, in the atmosphere, there's a lot of nitrogen. Atmospheric nitrogen is N2. And what this means is that this just is a symbol and a notification that lets us know that N2 contains 2 atoms of the element nitrogen. Now, when I say element, I'm referring to a pure substance that cannot be broken down into anything simpler or more stable. And you can always find out an element by just looking to see if it's on the periodic table. So in my class, we have these large periodic tables that we can kind of fold out of our binders that we're going to be referencing all the time. You're always going to have access to a periodic table. You don't need to memorize anything on this at all. But everything on this periodic table is an element. And again, atoms are a unit of an element. So N2, that's the element nitrogen, and it's 2 atoms of it, okay? Now, we can form compounds out of these. A compound is a pure substance that can be broken down into simple and more stable substances. So we can break it down into elements. It's formed when we chemically combine atoms of 2 or more elements. So for example, H2O. Let's read this one. This is 2 atoms of the element hydrogen, chemically bonded, chemically combined with 1 atom. If there's not a number, it's just understood that it's a 1. 1 atom of the element oxygen. So you just thought H2O was water, but look, you can say it so much fancier now. 2 atoms of the element hydrogen chemically combined with 1 atom of the element oxygen. You can find hydrogen, you can find oxygen on your periodic table. So those are elements. They're chemically combined and into a fixed proportion of 2 to 1, 2 hydrogens for every 1 oxygen. That's what gives us water. Okay, so we need to be able to classify matter to understand what it is. So all matter can kind of be split into 2 categories. It can be a substance or it can be a mixture. Substances are pure, meaning they have a fixed composition throughout. Water, like I said, is always 2 atoms of the element hydrogen with 1 atom of the element oxygen. It's always that 2-to-1 ratio. It's fixed throughout. Substances also have the same properties throughout. So if you have a glass of water, all of the water molecules that are in that glass behave the same. Remember, properties are just descriptions of how things will behave. So they're going to act the same way. So examples of substances: helium, oxygen, sodium chloride, that's table salt, C6H12O6, that's glucose, that's a sugar that's made in photosynthesis. These are all substances. They're the same throughout. They're elements and they're compounds. Okay? Sodium chloride is always 1 sodium chemically combined to 1 chlorine. Glucose is always 6 carbon atoms of the element carbon, 12 atoms of the element hydrogen, 6 atoms of the element oxygen, and they're always in this proportion. Okay, those are substances. Now, a mixture is a combination. It has a variable composition throughout. It's not the same throughout. And in a mixture, each component of the mixture retains its own unique properties. So for instance, sodium chloride together, this compound is a substance. It's table salt. You can eat it, okay? But it's not like sodium and chlorine. Sodium is explosive and chlorine is used to clean your pool, okay? But together, when they're chemically combined, they lose their unique properties as elements and they become a whole new thing that's table salt that's totally safe for you to eat. Okay, so that's what's different between a compound and a mixture. A mixture, it's going to still retain those same properties from what it had before. And we can separate mixtures into these substances. Okay, so for example, salt water. Salt water, still you can taste parts of salt and you can taste parts of water in it because it's just a mixture. It still retains its own properties within it. Okay, lemonade, your blood, air that you're breathing in, the air that surrounds you right now is not just oxygen. There's carbon dioxide you're breathing out. There's H2O, water vapor that's coming out, and moisture, especially if you live like where I live, where it's very humid all the time. There's a lot of moisture in the air. Okay, so there are things in the air. It's not just oxygen. All right, but we can further subdivide these more. So first, now we're going to break down substances even more, and then we're going to break down mixtures even more. Okay, so first let's talk about substances. Substances can be subdivided into elements and compounds. So elements, we already mentioned, are the simplest form of matter. You're going to find them on the periodic table. They can't be broken down into anything simpler or more stable. And they exist 2 ways. They can be 1 atom, which is monoatomic, or they can be 2 atoms, which is diatomic. Okay, so based on these pictures, this is what 1 atom would look like. See how they're all just 1 atom of the element, and then here they exist in 2s. So for example, magnesium is monoatomic. It exists just as like 1 atom of magnesium naturally. Carbon is monoatomic. It exists as just like 1 individual atom. Hydrogen naturally isn't just like floating around as 1 atom of hydrogen. It naturally is diatomic. So you'll naturally find 2 hydrogen atoms bonded together. Same with oxygen. It's not just O. It's 2 atoms of the element oxygen bonded together as diatomic. Both of these, though, are still just elements. Okay? Now, this is different from, watch how the picture changes, a compound. Notice that a compound, within this picture, we have different elements in here. So compounds are still substances, though. They're chemically combined atoms of 2 or more different elements. We've already written that down. This is an element, what it would look like. This is what a compound would look like. And it's got that fixed proportion written as a chemical formula. We can break them down into simpler substances. We can break them down into elements, but it's a chemical process. It's not like you just pull apart with your hands. You have to do a chemical reaction to break it down further. And because it's a chemical bond, there's different properties as a compound than the parts that make it up. So like we said, sodium chloride, carbon dioxide, C6H12O6, these are compounds. I can break C6H12O6 into carbons and hydrogens and oxygens, but it's going to take a chemical reaction to do it. And again, carbon dioxide has a different property than carbon does on its own and oxygen does on its own. Okay, so this is what compounds are. So that's the left side of this little flow chart. Now let's talk about the right side. Let's talk about those mixtures. Mixtures can be classified as homogeneous or heterogeneous. Okay, a homogeneous mixture, homo is a prefix that means same. So it has the same or an even distribution throughout. Oftentimes, homogeneous mixtures can be tricky because they appear blended. Okay, it looks like it's all mixed and consistent throughout. See how everything is just kind of equally dispersed in here? There's no like rhyme or reason to it. That's a homogeneous mixture. They can be physically broken down into their different components. All mixtures can. Okay, we can physically separate them out. Now, a solution is a homogeneous mixture where one substance, which is the solute, gets dissolved into another, which is the solvent. So think about when you've ever made like Kool-Aid at home. The Kool-Aid powder is your solute. It gets dissolved in water, which is the solvent, and it makes a solution, which is the drink Kool-Aid. Okay, and it appears blended, but technically it's just a mixture. You didn't do a chemical reaction right there when you just dissolved those into each other. Okay, now a specific type of solution is an aqueous solution. When that solute is dissolved in water, so solvent is water, then that's going to be considered an aqueous solution. Now, it doesn't always have to be like a powder into a liquid though. You can have a solutions of other things. Like you can have a solution of metals that's called an alloy, like stainless steel and bronze. Those are alloys. You just have to melt the metals into a liquid form before you can actually mix them together to make the solution. But those exist too. 14 karat gold, that is another alloy. Okay, so these are all examples of homogeneous mixtures. Now, watch how this picture changes. This is what a homogeneous mixture looks like. Again, I said it's kind of like has the same distribution throughout. Heterogeneous is really different, and it's more like weighted down, and it's really chunky because hetero is a prefix that means different. So it has an uneven distribution in the picture. Still, like with homogeneous, you can physically break down the mixture into its different components. And often in heterogeneous, we can see the different components really easily, or especially if you let them settle out, you'll see. They'll separate out over time. So think about like salad dressing, like Italian salad dressing, or if you think about paint may appear blended like a homogeneous mixture, but when you let a can of paint sit in your garage for a couple weeks, if you open that can of paint, it gets like watery along the top. You're gonna have to like shake it to mix it again because it separates out. Okay, so if it can separate out, that makes it a heterogeneous mixture. Okay, so this is like our overall flow chart for how to classify matter. And I'm not going to try to trip you up on these. I want you just to like understand it, but not be stressed by this and all the different nuances, okay? But if you want to just know the basics, here's like a basic summary of this, okay? So substances versus mixtures. Substances cannot be physically separated. Mixtures can be physically separated. To differentiate between the type of substances, which are elements and compounds, elements cannot be chemically broken down further. Compounds can, because they can be broken down into elements. All right, now let's go to mixtures. To separate homogeneous and heterogeneous, homogeneous mixtures have a uniform composition, okay? If you took 20 different samples from the same jar, they would all look the exact same throughout. Whereas heterogeneous mixture has a variable composition. It's uneven throughout. I could take 20 samples from a salad dressing container and all of them would be really different. Or think about a bowl of Lucky Charms cereal. If you had 20 different scoops of Lucky Charms cereal on your spoon, each spoonful would be different because the cereal has a variable composition with all the different marshmallows and stuff in it. Whereas a homogeneous mixture, something like multigrain Cheerios, it's more of an even composition throughout. Every bite would really taste the same because it has an even distribution of the different multigrain Cheerios. Okay, so in class, we're going to pause and we're going to put this into practice a little bit. But for the sake of the video, we're going to keep trucking forward and talking about now properties of matter. So like I said, the structure or the composition of matter determines how matter is then going to behave and how we can describe the matter. And how we describe matter and predict how it will behave are matter's properties. And properties help us distinguish between substances and also help us separate mixtures. Okay, so this is really helpful. Properties can be classified as extensive or instantive, and they can be classified as physical or chemical. So first, let's talk about extensive versus intensive properties. Extensive properties depend on the amount of matter that is present. So extensive properties are things like mass, volume, the amount of energy, etc. These are numbers and values and properties that will change. If you have more of them, you're going to have more mass or more volume. Okay, so like for example, aluminum can have a mass of 10 grams or a mass of 200 grams. It just depends on how much aluminum you have. Okay, intensive properties are different. They do not depend on the amount of matter that is present. So density is going to be the same. What of aluminum, whether you have 10 grams or 200, the density is the same. The melting point's the same. The boiling point's the same. The specific heat is the same. Okay, so again, for example, aluminum always has a density of 2.7 grams per centimeter cubed, regardless of if you have a few pieces versus giant sheets of it. Okay, now, one exception to this is water, which we're going to talk about a little bit. Water's density changes ever so slightly at different temperatures. But again, don't worry about that. In general, density is an intensive property. And we're going to be talking about boiling point and melting point and specific heat a lot later in our states of matter unit. But I'm just trying to start introducing you and familiarizing you with some of these terms that we're going to see down the road, okay? Like I said, properties can also be classified as physical or chemical. So a physical property can be observed without changing the identity of the substance. So if I'm looking at a substance and I want to kind of describe how it's going to behave or describe it in any sort of way, I can describe its color, the density of it, the mass of it, its boiling point, the state. Is it a solid, liquid, or gas? Okay, those are all things I can just describe about it, and I can see those just physically without changing the substance. And by state of matter, again, like I said, that's solid, liquid, gas, or plasma, which we'll talk about a little bit more later. But we have a whole unit coming on this. So just a brief intro. A solid has a defined volume and a defined shape. A definite volume, definite shape. Okay? A liquid has a definite volume, but the shape is indefinite. The shape changes based on the container that the liquid is in. And then a gas is indefinite of both. It has an indefinite shape, indefinite volume, okay? That's what makes these unique. We'll talk about plasma a little bit more later too. So physical properties are also, I like to always kind of put physical changes with these. So a physical change is a way that I can change a substance without changing its identity. And all I'm doing is just changing the physical properties of it. So for example, I can change state. I can boil something that takes it from a liquid to a gas. That doesn't change what it is. Like if I boil water, it's still water. It's just not liquid water anymore. It's gaseous water. It's water vapor. Or you can melt an ice cube. It's still H2O, still water, but it went from solid to liquid. Dissolving, vaporizing, grinding something up, like taking a solid and grinding it into a powder, cutting something in half. These are all just physical changes. They change the physical properties, but they don't change what the substance actually is. Okay? Chemical is different. Chemical properties, we can only observe them by changing the actual composition and identity of a substance. So if I want to see how reactive a substance is, how well it decomposes, how unstable it is, all of those things, in order just to observe or measure them, are going to require me to actually change the substance in order to do it. It's going to cause a chemical change, a change of a substance into another substance. And when a chemical change happens, a chemical reaction happens. Okay? So, for example, burning, oxidizing, rotting, corroding, fermenting, these are all chemical changes. Now, chemical changes do not have a change in the amount of matter. It just changes the amount of energy that is there. Okay, and that's really important. They don't change the amount of matter because of the law of conservation of matter, which hopefully you remember from physical science, which states that matter is never created or destroyed. It only changes forms. Okay, so if something looks like it disappears in chemistry, most likely it just got converted to a different form, to a gaseous form, and you just can't see it physically anymore, okay? But matter never gets destroyed, okay? So the amount of matter just doesn't change, just the type of matter and the energy changes when we do a chemical change. There's always a change in energy in a chemical change or a chemical reaction. Okay, and a couple of ways that you can tell if a chemical reaction happened to help you know, was this a chemical change or was this a physical change, is you can look for a few things. So you can look for a sudden release of light, a sudden change in temperature, a sudden color change, a sudden odor change. If an odor starts being given off, that can often be a sign of a new substance being formed and thus a chemical reaction or a chemical change. A gas being given off. We like to say if it effervesces, that's when it starts bubbling. That's usually a sign of a chemical reaction occurring. Another is the sudden appearance of a solid. So if you're adding a liquid to another liquid and all of a sudden it looks like a solid's appearing, that solid is called a precipitate. That is another sign that's evidence of a chemical reaction. Okay, so Again, I'm pulling this up again just to remind you that like a chemical change is the only way that we can break down a compound is by chemically doing a chemical change, doing a chemical reaction to break down a compound into elements. A physical change we can do with mixtures. We can physically separate mixtures. We cannot physically separate substances. We can only do chemical here. And so that's why I pull this up again. Okay, and again, so physical changes happen between substances and mixtures. Chemical changes happen between elements and compounds. All right, again, we're going to practice all this. We're also going to do some lab stations that I think will really help you see and experience some of these properties. So I hope this helps just kind of introduce you to properties and classification of matter.